This is a typical Newton's second law question. So in part A, you are told that the forward force A and the backward force B are equal. This means that the forces acting on the car is balanced. When there are balanced forces, there wouldn't be any resultant force. By Newton's second law, the acceleration of the car will therefore be zero. Hence, the car will move with a constant velocity. Now in part B, this is a typical calculation question for Newton's second law, and as forces are vector, it's super important for us to first define what is a positive direction. So for me, I let forward direction be positive. So force A will take a positive value and force B will become a negative value later on. So I will start by using Newton's second law, F equals to ma, to calculate out what is the resultant force acting on the car. The mass is given to be 800, the acceleration is given to be positive 1.5 meter per second square. So this means that on the car itself, when I sum up all the forces here, the resultant force on the car is 1200 Newton. So I literally sum up all the forces as shown in the equation, rearrange the equation to make force B the subject of the equation, and that's how I can get force B to be negative 3800 Newton. This means that force B takes the value of 3800 Newtons and is acting in the opposite, which is the backwards direction, as shown by the negative sign. In part C, you are asked to explain why the acceleration decreases when the driving force, which is force A, remains at 5000 Newton. Now, there is an acceleration of the car when the engine force becomes 5000 Newton, so the car will speed up. But as the car speeds up, the air resistant force will increase over here. You get this feeling also in your everyday life, whether you are running or in the moving car, wind down the window. As you move faster, the wind on your face becomes stronger. So this shows that air resistant force increases as you move faster. Now, this means that force B will become gradually bigger and bigger and bigger as the car moves faster and faster and faster. This therefore results, or rather this is represented by a decreasing acceleration. So the car will still speed up as per usual, but the more it speeds up, the more difficult it is to speed up, because the air resistant force becomes very, very big.